thinking about the sector overall and how to improve that, but part of it is also we've made a commitment to open source as much of our work as possible. So when we take on a new project or new campaign around some of our core areas like impact investing or inclusive entrepreneurship, we say, okay, well, if there's a tech build involved.
This is the Computer Programming University, where learning is always fun, as it should be. This is a GitHub Universe 2018 live demo desk. Enjoy.
Really flesh out a lot is in our marketing communications work. So we released an analytics dashboard this year that talks to a couple different marketing tools we use and presents a really nice display of how different campaigns are running. And so we've shared that with several nonprofits. And it's a turnkey solution. It's open source. It works with kind of common platforms like Google Analytics and MailChimp. But it's been really exciting to see other nonprofits be like, wow, like no other tool does that in exactly the way we think about our marketing communications as a nonprofit. So we've been able to like tune this project to fit how other nonprofits think about their marketing communications work. So that's what we're really excited about, is when we do our own work, saying, okay, how can we be philanthropic and accomplish our sort of internal or mission goals at the same time? So open sourcing, again, as much of the tech we produce or fund the production of as possible.
Okay, that's a great example, and I think it really demonstrates the power of open source. This idea of unleashing collaboration in ways that are new and different. One of the things that's most exciting about the work that you're doing is that all of it is happening on GitHub.
Yes.
And I suspect that you are not the only social actor out there that is using GitHub in this way. And I think our work is about really amplifying and lifting up the great work that folks like you are doing and the Case Foundation is doing. What are some ways that you've been able to leverage the GitHub ecosystem in your work?
Yeah, no, absolutely. It's a great question. The core collaboration tools of GitHub are the most awesome thing we take advantage of. Pull requests, issues, particularly issues, because when we talk to nonprofit actors, philanthropic actors, that's the medium in which they can give back opinions and collaborate and say like, hey, it'd be great if this project did this or did that. So those core collaboration tools are so well relied upon to really share ideas and build great products.
And I think you would hear that from many other social sector actors as well, is that the collaboration aspect of the GitHub platform is one of the most, just invigorating for the work.
No, it absolutely is. And the other thing we're thinking a lot about is discoverability of projects. As we talk to more nonprofits and more organizations working on change-making ideas, they say, where can we go to find these great projects? And so educating those groups about how to use GitHub to find projects and to really dig in is something we're also thinking about a lot. But exposing the great projects is something I think a lot about. That I talk to a lot of individuals working on great open source projects and different nonprofits who have open sourced their work and say, like, how do we get people using them? Like, we're so excited to share them. Like, how do I get users? So that education process and teaching them how to leverage the platform to gain exposure is something I think a lot about.
Great. Well, I know that you and I have talked quite a bit about sharing both our work, and one of our goals within our social impact and focus is really thinking about how we can better leverage the GitHub product and platform and support, philanthropic organizations and nonprofits who are involved in the open source movement. So I'm looking forward to working with you all a lot more.
Very excited about that as well.
Those pieces, right. Well, then I'll go to my last question. What do you think is the future for open source and philanthropy?
Increasing engagement, getting more nonprofits to think about how to give back. And I also, a big part of it too is going to be working with companies to help them understand how they can use open source to give back. That when they think about ways to contribute, the way to have social impact, open source is a way to have social impact. And a way to be philanthropic as a private company. So working with tech companies to say, hey, your developers, like, they want to volunteer, they want to give back to causes they care about. Let's think about ways to make all that work together. And it goes back to what we said, like getting these two worlds to really work together really well. Refining that, creating the environment in which that happens is kind of the road ahead for us.
Great. Well, thank you, John. I'm just so excited that you could join us for GitHub Universe. I'm excited for our conversation this morning, but also for our breakout session tomorrow afternoon at 1:20.
Yes,
well, you'll
be there or be square.
Be there or be square to hear more about the Case Foundation's work, as well as other ways in which developers are really using code and software to make a difference in the world. So thank you, John, for your conversation
today. Thank you so much.
Wonderful. Okay, all right. Enjoy.
We're good to go? Oh, right on. Ooh. How you doing? My name is Bill Manning. I am a solution engineer at JFrog. I want to talk to you today about what I say wibbly wobbly, timey-wimey binaries. If you're a fan of Doctor Who, you will know that that's actually one of the things. So basically, I'm going to talk to you today about what is Artifactory, what is JFrog, where does JFrog fit into here, and why are we here at GitHub Universe talking about binaries? Well, it's very simple. Where you have GitHub and you use that for everything around your source control and managing your code, building branches, doing all the things you do. When you produce code, you have third-party libraries. Well, those third-party libraries should be managed also, and that's what Artifactory does. We call ourselves the Universal Binary Repository Manager, and what that means is that we handle the dependencies, we handle the builds that you produce with the code that you have, that you use your GitHub source code, and then you have artifacts that are around it also. As stated, I'm William Manning. If you follow me on Twitter, you can also follow JFrog on Twitter at JFrog. And let's talk about standard development cycles. So in a standard cycle where you have things like GitHub and you're using it for your code, you plan all your binary releases, you plan how you're going to do things, you test, you release, you deploy. Well, where Artifactory comes in is a couple different ways. Think of it as like a conveyor belt as you're going through your development process. And from your source code, from your code development, all the way down to your deployment, all the way down to your releases, we can be there. So everything from those third-party libraries all the way down to the actual release itself. And the entire way, we try to scope the DevOps experience around what we do. We're not exactly the most forefront technology you'll have out there, but we're essential. And this allows you to have control over everything you do. Whenever I talk about how you use Artifactory or use our suite of products, what we do is we provide consistency. So consistency from the time your developers are developing all the way down to the time you release your software. Having that consistency throughout it ensures a steady release. Another thing we do is we also talk about simplicity. How do you actually implement Artifactory and make it so that it's part of what you do and it's behind the scenes, you don't even realize it's there. And we'll talk about that today also. And the last bit we're going to talk about is security. How do you ensure that the binaries that you're actually depending on are are safe and going to actually keep your organization functional and not have any sort of security vulnerabilities? And we'll touch upon that also. So the suite of products that JFrog offers is a couple different things. So in the beginning, you can see where you have your Jenkins server safe, your CI, GitHub for when you do your check-ins, and you might want to deploy, say, a web service at the far end of this and say Kubernetes. Well, along the way, we have a whole series of products. We have Artifactory, the Universal Binary Repository Manager. We have our actual X-ray product, which actually scans those binaries, those third-party libraries, the builds you produce, to look for anything nefarious, anything that might cause issues in your organization. We have our product called Mission Control and Insight. This is all part of our higher-level platform, but Mission Control, if you have multi-site deployments, it allows you to kind of manage the entire system of your DevOps org. We have BinTray, which is actually our SaaS product, which allows you to distribute your binaries globally, and it's based on Akamai CDN, but also, too, we have our Enterprise Plus platform, where we've taken that, and you can actually distribute your own binaries based on your own CDM schema. So in a typical web server, you might have a whole bunch of things. You have a whole series of projects that you use. You have dependencies that depend on others. And one of the things I always talk about whenever I talk to organizations on how to think about using Artifactory in our suite of products in their org, the main thing that we come about with is planning. How do you plan your releases? Well, you should also plan the way you move binaries through the system. You have something like a Docker container, which contains many GitHub projects that are inside. Dependencies, the code itself, the core OS, all these kind of things. I mean, you can store your Docker files inside of GitHub and all that, but everything around it is encapsulated in it. So Artifactory can attribute to all these different layers of the Docker container. And by having that, you can make sure that those releases are just strategically, well done. But also, too, if you're starting to deploy out to a web service, you're also going to want to have something like Kubernetes. And the thing is that you can see here, besides being a Kubernetes registry, besides being a Docker registry, besides the multitude, and I'll show you all the various binary types that you can do, you can use Artifactory from its inception to its delivery. I'm going to go and do a quick demo now, and I'm going to talk about Artifactory. I'm going to show you an example of where you can utilize it in, say, a web server. So like a web service is a very typical situation where you have code, you go through, you want to have your CI and your CD be as rapid as possible, you want to build as fast, you want to release as fast as possible, get it out there to the users. Well, how do you do that? Well, Artifactory can help you do that. So this is Artifactory itself. This is our screen. Now, I always preface it by saying that everything you see here in the UI is based on our API. So this is just a simple Angular 2 user interface on top of that. We also have a CLI tool out there. And one of the main benefits I actually want to touch on immediately is Artifactory has one key component that makes it even more robust. We use a checksum-based storage, and that checksum-based storage allows for more speed, accuracy, and efficiency, also removal of duplication. So any of those third-party libraries you're pulling in, say you have 1,000 projects, you would only store that once and everything is referenced via metadata. Now, the other part of the metadata side is being able to customize metadata around your organization, which is more pertinent to you. Now, I did mention the fact that we provide consistency, so I want to talk about a couple of different things in here. So we are universal, so if I were to go in here and look at local repositories, now local repositories are repositories that matter to your organizations. Those are your builds. So when you do, say, a CI build using something like a Jenkins server, you pull in your projects, you pull in your third-party dependencies, and you build it out, and you want to deploy it somewhere, well, where would you store it? Normally, some people store it in an NFS, they store it somewhere else. Well, actually, Artifactory is probably your best option. And the reason why is we collect a whole series of metadata around that. It allows you to go back and look at it, evaluate it. If you have problems with it, it allows you to have remediation. It's a full, robust system that will allow your organization to excel in terms of development. So if I were to look at this, you could see all the various different types of repositories in which we actually, you can use. Everything from, say, Conan for CC++. If you're doing this sort of development in Python, NPM development, you name it, we can do it. You can also, like I said, use this as also a secure Docker registry, so you keep everything together. We have remote repositories, which are those third-party binaries that you are utilizing. And what we do is we do a cache proxy. So in other words, when you request those binaries, instead of having to go every time for every developer, for your CI, for your release, going out to the outside world, you can actually just have them pull into Artifactory and then deploy all around to your other parts of the organization. On top of that, you can apply our X-ray product, which I'll show you in a few minutes, which will scan those binaries to make sure they're safe and also allow compliance in terms of things like license governance. Now, I mentioned the fact that in Artifactory, if you wanted to deploy this and you want to have that simplicity, I'm going to show that. And then I want to talk about the CI/CD process and also development process from GitHub all the way down to your deployment. So one of the things that we do as a company is we provide nice, easy setup instructions. So if I were to create something around, say I'm a Gradle developer and I wanted to create something around that, we actually provide you with the easy setup instructions on how to actually generate that to actually set it up for your product. And the thing is that whenever JFrog takes on a new package type, we study it, we break it down, we build it into the product, and we learn to see how we can work within the natural paradigms of that package. So in other words, once you've implemented this as your solution to store those binaries, to get those third-party binaries, it seems natural. So if you were doing Docker, it would be Docker tag, Docker push, Docker pull. If you're doing anything with, say Python, it would be pip install. We try to keep it as native as possible. So once it's implemented, there's no deviation from the way your developers use it and the way your CI system uses it. Let's go take a look at what a typical job would look like. So I have an example here, and I want to show how along the way, every step in here, Artifactory is involved. This would be a typical workflow that you would have, say, in something like a web service, right? Where you actually have a back end, you have a front end, you have a container to encapsulate it, you're then deploying it under a service, such as Kubernetes, and you're deploying it out. Now, the entire method that you're going through here, if you look, I've got a Java backend, I've got a Node front end, I've got a Docker container, I'm creating a dynamic Helm chart. So this chart is actually being created based on the information above it. And I have these as actually a series of builds that are queued off by check-ins. So if I was to check in the code for my Gradle app that I have here, it would queue off the build of my CI/CD system, in this case Jenkins, and it will go through the subsequent steps to produce that web service. Now, the entire way that I'm doing this, not only am I consuming the source code from GitHub, I'm consuming the binaries, those third-party libraries that I depend on to build my products from Artifactory, but I'm also taking the end result of that and I'm storing it back in Artifactory. And that allows me to have a system of record, and I'm able to actually go through and look at the way things are being promoted through the system. Now, in addition to that, I mentioned planning earlier. So if I'm doing these kind of builds that I have here, one of the things that I want to ensure is that my repositories, the repositories I have in Artifactory, match my structure. And when I say that, it means everything from, say, planning with like development, QA, testing, staging, and release. And we have a thing called a promotion API inside of the actual product itself that allows you to have that system of record. In this case, I'm actually going to focus on one particular build here. And the build I'm going to be focusing on here actually has its Docker file stored in GitHub. It's actually, in this case, the build I'm doing is I'm cloning the project. I'm actually grabbing its dependencies from Artifactory. So the two previous builds, I have a Node front end and I have a Java back end. I'm actually building a container. I'm putting that container back into Artifactory. I'm running a unit test around that, and I'm providing more additional metadata back to say whether it passed or failed my test on this particular build. I'm actually performing an X-ray vulnerability scan to see if all the contents in there are actually safe and secure for my release. If they pass my litmus test on all of these, I then promote it from my staging repository up into my production repository for deployment. And what would that look like? Well, let's go take a look. As I mentioned before, I'm going to be storing all my builds into Artifactory. So everything that I'm doing as a developer, I can take it. I can either manually do it. I can do it through an automated process. We also have a CLI tool that will allow you to actually manually upload some of these. But the example I just showed you, what does that produce? Well, if I take a look here, here's the actual build that I referenced back in Jenkins. And when I show the build information that's around this, I can see everything that was produced during that build time, right? So here's the actual layers of that container. I can also show you the two previous components that I had, where here's my front end and my back end. I can look at all the environmental variables, all the system variables. If I have this connected to a Jira system, I can see what issues are there. I can look at all the licensing that's inside of this. But my biggest thing is that by having all this consolidated information, all this metadata around this build, one of the things is if you've ever worked with, say, something that's very high complex, such as a container, I can go in here and actually do a diff. So now the builds that I produce in my automated process, if I need some sort of remediation behind this, I can go in and actually take a look and see what's changed. Everything from the artifact level of the layers, the container I produced, down to any dependencies. So if you look here, I've got a change in my UI, and I made the change there. And then lastly, I can see if any environmental variables have changed. Last thing I want to touch on is security. So I just kind of want to show you with our X-ray product, I'll just show you an example of how bad it could get. So the application I just showed you right there, one of the things that's around it is the fact that I actually went through and I made the worst of the worst in terms of what's inside of this container. If I do a search, and this is where binaries matter, and the reason why we are as a company is if you look here, I've actually got a container here that has a jar file inside of a jar, inside of a layer, inside of a build, and this one actually caused the leak of 140 million records. So as a whole, being able to encapsulate what we do as a company is the fact that we can manage your binaries from your dependencies down to your releases. You can go through and see how things were promoted. So like when I was showing before, in terms of this build that I had here, I have a release history to let me know this was released. And we can actually, where GitHub manages all your source code and does it excellent, we do the same thing in terms of binaries and your releases. Thank you so much. I'm Bill Manning. If you have any questions, you can go to try.jfry.com and follow us there.
I'm Nico from Code Climate. Today I will be showing you the latest and greatest from Code Climate. For those of you that are unfamiliar with us, we build software to help development teams streamline and optimize their pull request process. Code Climate is all about helping engineering teams make better decisions about their pull requests, processes, and code. So this latest feature set that we have came about because a while back we were thinking about the different ways that we could help development teams get through their day-to-day workflow. And our data science team did some analysis and found that about 8% of all pull requests that are opened never end up merging. And the thing that came out to us about this was that means that 8% of your team's time, 8% of their effort, gets to the point where they have written code that they feel like is ready to be reviewed, but somehow doesn't make it into the system. So that's 8% of everything that your team is doing on a day-in, day-out basis, your team isn't realizing value from for some odd reason. So what we did is we took a look at the millions of pull requests that have gone through Code Climate, and our data science team ran some more analysis to start to figure out why exactly those 8% of pull requests didn't end up getting merged. And they identified a series of leading indicators, sort of flags for certain pull requests that are less likely to ever make it into production successfully. So what I'm going to show you today is the productization of that data science work into an application that will help you understand and identify potential risky PRs or areas of your process that might be creating a bottleneck before it comes to the point of something never getting merged in the first place. So what you're seeing here is our dashboard screen. And I mentioned that approximately 8% of pull requests never end up getting merged or finding their way into production. So everything below this 0 line represents a pull request, so in a given period of time. So the way to read this bar is that for the week of August 27th, 12 pull requests that we opened ended up closed, stopped merging. And the black are reverts, and we also track long-running and active pull requests. So we found that pull requests that are open for more than 2 weeks without any activity, no commits, no comments, nothing, the chance of those pull requests ever merging drops precipitously, so close to 0 that it might as well be 0. So we track those in and bucket those into potential waste that's going through your system. Above the 0 line are the pull requests that are successfully merged. So the way to read this would be that the week of September 10th, we merged 108 pull requests. 9 were closed, stopped merging. 2 fell into a long-running and active state, and then 3 were reverted. So the thinking here is, okay, I want my team to merge more pull requests, abandon fewer, and merge them faster. So this is cycle time, and cycle time tracks how long it takes from a pull request to go from first commit all the way through to merged. But in reality, you just can't tell your team to merge more, to merge faster, to abandon less. So the data science team, as I mentioned, found some leading indicators, which we refer to as drivers. And if those leading indicators are potentially problematic, that could be a sign that a pull request might fall off the rails and never get merged. So PR size is one, and I will show you a bit about that. So this chart, similar to the way that the other chart looks at over time, how many pull requests did we merge, how many were abandoned, and how quickly. This chart looks at, of those pull requests that we opened, how big are they? So if I go to October 8th, what I can see is that of all the pull requests that my team opened the week of October 8th, 4% of them were greater than 1,000 lines. 56% of them were between 0 and 50 lines. And I just get a full percentile breakdown by size of all of my PRs. So what you can do, and what we found, is that larger pull requests are much less likely to merge than smaller PRs. So if somebody opens up a potentially large pull request, that is an inherent risk. Developers find it harder to review, say 3,000 lines rather than 10 or 50 or 100. So as a team, being able to flag this upstream and encourage breaking up your work into smaller chunks and measure that as you work is a way of ensuring that this work never falls into that long-running and active state, or that this work gets abandoned and never merged in the first place. Another one of those leading indicators is review cycles. So this chart is looking at pull requests that are going through a lot of iteration. So one review cycle would be somebody opens up a pull request and then a developer writes LGTM and it gets merged. That's one cycle. 2 review cycles would be a developer opens up a pull request and somebody says, hey, I think that you structured this method in a way that might not be the best. Can you take another stab at this? And they fix it and so forth. When you get to the point of 7, 8, 10, 20 review cycles, that's a pull request that is inherently riskier and less likely to merge than one that goes through, say, 1 or 2 or 3. So the idea here is that you're going to be able to flag and identify pull requests that are going through a high number of review cycles so that this work doesn't fall into that category of long-running, inactive, or ultimately never merged. Speaking of pull requests that have never been merged, we also wanted to raise the visibility of PRs that have been long-running and open for a long time. So one thing that has come up a lot is that pull requests that are open for a super long period of time, the chance of those PRs ever getting merged falls closer to 0. So being able to visualize for your team how many open PRs there are is a great way of raising the visibility of a piece of work that might be falling into this long-running and active state. So if you see a PR that is between 0 and 7 days old, that could be, okay, we're working on it, we're going to get this merged. 7 to 14 is, I think that we should take a look at this as a team to make sure that this work is cleaned up, gets merged in successfully. And then when things start getting into the 14 to 30, 30 to 60, 60 to 90, 90 plus, this is work that is very risky. So having your team come in, look at this, make sure that there's no merge conflicts, understand if this work is still mergeable is really important. Now, one thing that we found is that the pull requests that end up in this long-running and active state tend to fall into one of the other negative leading indicator categories that we've created. So, for example, I gave you 2 earlier, large changes, big PR size, and a lot of review cycles. Typically, you'll find pull requests that are in this 90-plus days category to have those sort of things. We have a lot of different leading indicators, and I'll just cover some of them very briefly to give you a flavor for some of the other things that we track. So PR size is one. Time to open looks at how quickly a developer goes from first commit through to opening up a pull request. And this one is really focused on tracking, are people suffering from context switching? Because if somebody pushes up a commit and they don't open up a pull request in a long period of time, it's a potential signal that they might have gotten stuck onto something else or pulled into another direction, and that's an inherent red flag and a risk. Another one is time to review. So this one is all about making sure that your developers, when their pull requests, when that review is requested, that the review actually happens. So in a lot of cases, at least on our team, we found that somebody will finish a piece of work and say, hey, this is ready for review. They'll pass it up. The reviewer takes a look at it, but then gets pulled in another direction, and that review can sit open for 3-4 days. And that sort of context switching is really detrimental for your team. That again can lead to this case where pull requests are falling into potentially a long-running and active state just because somebody forgot to review it, and then as the team moves on, they have to go back and think about that old work that could have gotten merged into production a little bit faster. And we've covered review cycles. Unreviewed PRs is exactly what it sounds like. Pull requests that your team is opening and somebody just went ahead and merged themselves. And a good way of visualizing all of these different leading indicators is this Teams tab. So this tab breaks down on a team-by-team basis all of these leading indicators, which we've grouped here into work habits, code review, and efficiency by each one of your teams. So at Code Climate, we have 4 teams. We've got a data team that does our data analysis. We have an enterprise team that's focused on making Code Climate great for large businesses. We have our velocity team, which is working on some of the features that you're looking at right now. We have a testing team, which is what it sounds like. And for each of these teams, we have the leading indicators. So for the testing team, their time to open on average is less than an hour. So that's great. And the reason this cell is shaded green is because we used industry benchmarking from the thousands of Code Climate customers that we have to say that we are in the top 5 percentile for this metric. So if you come to the Teams tab and you say, oh, wow, one team is in the bottom 25th percentile or the bottom 10th percentile of a metric, that can be a metric that you might want to dig into and learn a little bit more about. This is a great place to start conversations about where something might be where there might be a bottleneck in your process or where in your work there could be an area for improvement. We've noticed that for some of our teams, we have a relatively high revert rate compared to the industry average. And that's really been really been related to the fact that we're moving really quickly. So we're trying to ship things out, we're pulling things back, but that's a potential negative because we're pushing work in and we're pulling it out. Abandoned PRs, too, is something that we've been talking about as a team, and this chart has really helped raise the visibility of some of those potential negative leading indicators for our organization. So what I've showed so far is a lot of data, a lot of analytics to help guide you towards spurring better conversations and raising the visibility of certain problems. But the other thing that you can do with Code Climate is actually assign a risk flag to a pull request. So you'll notice here that this PR by Noah, one of our developers, who's actually here at GitHub Universe with us, is labeled inactive. So inactive is a risk flag that you can set, and you can tune all these thresholds for all the different flags that we have. We internally set ours at 7 days. So if somebody opens up a pull request and there hasn't been a commit or a comment or any activity in 7 days, we flag that PR as inactive. And a proactive notification can be sent via Slack. We have a team channel set up so that whenever a pull request falls into that inactive state, we get that notification, and it raises the visibility to the entire team that we have a PR that could be potentially going off the rails. Some of the other ones, and I talked about these a little bit earlier, are waiting for review. So Felipe opened up this PR, and it's been open for 175 days. It still has not received an initial review. It's obviously inactive, and new to Codebase means that it's Felipe's first PR to this repository. Yeah, first PR to this repository, which is another inherent risk. And you'll see the assigned reviewer. So this idea of using this data, the data that we present in the application, to understand your team's processes and how they work, and then coming back and setting, hey, this is a problem. We want to raise the visibility of this. Let's flag this as potentially risky at X threshold, and then using these notifications is a great way of getting all of this information into your team's development process. So you can also search through PRs to find areas that might be potentially problematic. So if I go here, and I want to filter by open PRs that are waiting for review, and apply. These are the pull requests that are currently open that haven't got an initial code review. So initial code review for this application means either somebody using the GitHub approvals feature or just a comment on the PR. And we've used this. Ours is relatively low, but it wasn't always this way. We've used this to make sure that work isn't sitting out waiting for review for extremely long periods of time, and that work is moving through the system well. So back to the start. If you do all of these things, if you focus on leading indicators like keeping your pull requests small and making sure they're reviewed in a timely fashion and flagging pull requests that are going through a lot of review cycles that are potentially risky, eventually, hopefully, you'll see the number of pull requests that are abandoned or fall into a long-running inactive state decrease, and the number of pull requests that end up getting merged increase, and the speed of which work goes through the system, first commit all the way through to merge, to get faster. So that's the end goal of this application, and the real driver here is that if you can do all of these things, it's a great way of having a quantitative data conversation about your pull request process and ways to continually improve your team. So if you're interested in learning more about Code Climate, we have a booth upstairs, and please stop by. We'd be happy to give you a demo and talk about how you can get set up with a trial to look at some of your own data. We obviously integrate with GitHub and via GitHub Apps, so it's a quick, super easy setup. We also support GitHub Enterprise. And if you're on the live stream and interested in learning more, head to codeclimate.com. And one of our developers, Chris Holton, is going to be giving a talk at the Helicline room at 4:30. So please stop by, and he's going to be giving a chat about how we actually move this Velocity application onto GitHub Apps and some of the technical challenges there if you want to get a look into what's under the hood here. Thanks.
All right. I will go ahead and get started. So here with CloudBees, I wanted to say thank you to GitHub for creating an amazing event. I don't think I've actually been to a conference that is this unique. So I'm going to jump right in. We have internet? All right. Let me check something real quick here. All right, here we go. So, my name is Casey Vega. I am a senior solutions architect with CloudBees. I just wanted to say hello to everybody. When I'm not working with our customers, I'm also a trainer for CloudBees and a consultant for CloudBees as well. At CloudBees, we're doing some pretty unique things in the space of CI/CD. If you're familiar with the Jenkins project, CloudBees is an enterprise sponsor of that particular project, and we're actually currently working on building the world's first end-to-end continuous software delivery system. As mentioned, we are the #1 Jenkins corporate sponsor, so about 80% of the code that we write winds back up in the open source project, and that's something not a lot of companies do that, and so that's something we're actually super proud of. We have quite a bit of users, many implementations, and if you're interested in how we derive these stats, you can go to stats.jenkins.io. Besides being the company behind Enterprise Jenkins, our DNA is deeply rooted in companies like Sun Microsystems and Red Hat. The creator of Jenkins is also the CTO of CloudBees. From the enterprise perspective, we're servicing most of Fortune 100 companies, and we work with varying different company sizes, large, small. So. And of course, we're hiring. So and I just actually ripped this straight off of Glassdoor. And I will agree with these statements. I have a pretty good work-life balance, and I have a lot of fun working at CloudBees. So most of our positions are remote, and we are located all over the world. So we have people in Switzerland, Spain, the United States, Australia, Japan, Dubai. So for anybody that's interested in traveling and working at the same time, that's definitely an option with CloudBees. So my demos today, I'm going to try to keep them fun. And if you know what this is, awesome. If you don't, I'm sorry. And the two demos I want to give today are how to use GitHub organizations in CloudBees Core and Jenkins. So this is available in our enterprise software offering, and it's also available from an open source perspective. So if you're using open source, this is something that you'll be able to utilize right away. The next piece of my demo is distributed teams and masters using our enterprise products. One of the things that our customers come to us for are, how do I scale Jenkins? I have 30,000 users and over 500 teams. How do I ensure that all of my teams are building software, that it's getting tested, and that the right things are happening? How do I ensure that my software is being delivered? And so today we're going to show you a really simple onboarding process that we've created on the enterprise side. Before we can do that, I wanted to talk about Jenkins file. Anyone here familiar with Jenkins file? Do you write Jenkins file? Awesome. So as you know, Jenkins, the entire purpose of Jenkins file or marker file is we set this file in the base of our repo, and that's configurable, but for this discussion, the base of our repo. And what we can do here is describe not only how we want our software built, but we can also describe how we want it tested, how we want it shipped, how we want it packaged, what other jobs that, once this one's finished, maybe there's other chores to go off and do. So what we really want people to do, especially GitHub users, is to commit their code and then to have that code work its way all the way into development without having as little much human intervention as possible. The entire purpose of Jenkins file is obviously to keep your builds and your deployments consistent, and code is, or configuration is code. So if you're not familiar with Jenkins file, that's fine. I think you'll understand it a little bit more when I jump into the demonstrations. So this is where we really want to get a lot of our users, and this is what a lot of people at a lot of companies are aspiring to do, right? They want code that gets committed to end up in production. But that's not always as easy as this chart makes it look. There's a lot of difficulties, right? We have the test team, we have the DevOps team, maybe we have a specialized team for our artifact repositories. So it really just depends on what type of constraints you have in your environment. But the thing that I love about Jenkins and CloudBees core is that I can really bend this software to my will and make it do what I want it to do. So what I'm going to show you today is an easy way to get up and running. Since this is, a GitHub conference, I figured we'll show you how to get up and running in GitHub and how to pull in all of the information that you have in your current repositories and how to take advantage of the Jenkins file. And it's really simple. So let's see, where's my, there we go. So this is my GitHub organization, right? And so a lot of people are probably pretty used to seeing this type of screen internally. Maybe you're running GitHub Enterprise, but here we have a couple repositories, and this was something I set up for the sake of doing the demo. But so we have a couple people, we have a couple teams right here, and then we have our repositories. And that's great. When we look at our repositories, we have code inside of them, and it's ready to take on work. So, oops. Here I have, and let's just make sure that this is going to load properly. All right, excellent. So here I have an empty Jenkins server, and it's ready for jobs, right? And so what we used to do way back is people would come and they would create a freestyle project. Maybe you're on, maybe you don't like freestyle projects because you have to tuck all the data inside of Jenkins. So people started evolving and utilizing pipeline projects. And that's great, but if you have 30 projects, that means you have to go and configure 30 jobs. And who wants to do that? I don't. So we started looking at multi-branch pipelines. And multi-branch pipelines bring in a lot of the nuances that you'll find in Git, right? So maybe I have additional branches or tags, and that's great. But again, I still have to configure each and every repository in order to do that. So what we came up with was GitHub organization project type. And so wish me luck, because this is a live demo on a live Kubernetes system. So let's go ahead and give it a shot. So All right, so that's the name of our organization. We have GitHub organization here. Click OK. So now it's going to bring me into the configuration screen. Now, one of the things that I did, because this is a demo,